Okay, welcome to lesson 9 of module 4. We're still talking about linear equations. This lesson is going to give you a chance to really apply linear equations. There's no new information here, but just lots of practice. But just a couple words before we start. I'm going to do the short version of this lesson, and so we are going to skip exercises 1 and 2 for now. When we come back in January, we may pull this back up, and I'll give you some notes for it at that time. But for now, we're going to skip exercise 1 and 2, and what that means is that you are also going to skip, and you'll want to write this down. Just maybe note it on your pages right now. Skip number 1 on the exit ticket, and skip number 1 of the problem set, because they're all of a type of problem that we're not going to do. However, if you've looked at our problem of the month, double down. The level C is called Love That Pig, and it's very similar to this. So if you want to look in the teacher notes and get a preview, you could do that. Otherwise, in January, we'll look at it. Okay, so for now, we're going to also skip down over exercises 1 and 2 in the classwork, because it has to do with that part that we're skipping. So turn to this page, and you'll see exercises 3 through 11, and those are the ones we're going to work on. So let's tackle exercise 3 first. We'll go back and forth depending on how you feel about, how confident you feel about transcribing these word problems and then solving the equations. You may want to do it step by step with me, but most of you are going to want to try it on your own first so that you can, really work your brain out and see if you can do these. If you don't get them all, don't worry. This is all about practice and getting familiar with it. So let's look at number 3. Marvin paid an entrance fee of $5 plus an additional $1.25 per game at a local arcade. Altogether, he spent $26.25. Write and solve an equation to determine how many games Marvin played. Okay, so I know the temptation here is to just find an answer. And I know that, and that's fine. And many of you will want to do that, and you can do that, and that's a good way to check to make sure the equation that you wrote is accurate. But in order to really do these, you're going to want to write the equations, because there will come a time when you will need to be able to write the equation. You won't be able to just work out the numbers from the problem, and so you'll want to have these skills. So we're going to do it that way, and you can double check it with any other way that you want. So here we go. So the first thing when we are transcribing these equations, remember, is to define our variable. So what is something in this situation that can change? Well, the entrance fee is just a one-time thing, so there's no variable there. But the per game cost, depending on how many games he plays, his total fee is going to change. So let's let X be the number of games he plays. Okay, so if we let X be the number of games played, what I want to do is I want to represent his total cost, is equal to the entrance fee plus the per game fee. Okay, excuse my handwriting. So we've got kind of this thing going on. So my total cost, I have to pay to get in, even if I don't do any games, and then I have to pay per game. So let's just put in what we know. We know the total cost is $26.25, and we know the entrance fee is $5. And the per game fee is going to be $1.25 times however many games he plays. So that's going to be 1.25x, $1.25x. So we have now defined our variable and written an equation. So now what we need to do is solve our equation. So let's get a clean screen and do that. Okay, so here's our equation that we came up with, and let's begin to solve it now. So I want to get x by itself. So if I subtract 5, I'm going to put $5 there, from both sides of this equation, then I'm going to end up with an equivalent equation. So this is going to be 2125 is equal to 1.25x. So now I just need to find out how many times I need to multiply 1.25 to get x, and the way I'm going to do that is by dividing by 1.25. 1.25, or how many 1.25s are in 2125? Okay, so it turns out that this is 17. Okay, so Marvin played, you always want to answer these questions, okay, not just tell me what the variable is. Marvin played 17 games. Okay, so so that's the first one there. Okay, let's look at number 4 now. And again, try it yourself. Pause the video now before you see my solution. Okay, number 4 says the sum of 4 consecutive numbers is -26. What are the numbers? So we did this back in the first couple lessons of this module, where we know that consecutive numbers are just numbers that come in a row. So examples would be 3, 4, 5, and 6. Those would be 4 consecutive numbers, but I could have -1, 0, 1, 2. Those would be consecutive numbers as well. Okay, so the way we're going to represent those is by letting x, let x be the first number. And the reason I do that is because then the other numbers that come after, to find the next consecutive number, is just x plus 1, x plus 2, and so on. So if we let x be the first number, then our equation is going to be, I want the sum of the 4 consecutive numbers. So there's the first one. Here's the second one. Here's the third one, be x plus 2. They're just one more. And here's the fourth one, would be x plus 3. Okay, so the sum, there's the sum of 4 consecutive numbers, and I'm told that that is -26. So now what I want to do is rearrange this. X plus x plus x plus x is 4x. And then 1 plus 2 plus 3 is 6. 4x plus 6 is equal to -26. Let's go ahead now and use our properties of equality. Subtract 6. Okay, and here's where most of the errors are being made on problems that I see in your work. This is 4x now on this side of the equation, because +6 minus 6 is 0. So that's 4x plus 0. Now, -26 minus 6, if you think of the number line here, I'm at, if I'm down here at -26, and I want to subtract 6, I'm hopping that way on the number line. So I'm going to add these two numbers. I could think of it as -26 plus a -6. So this is -32. And so we can see that x is, if I I'll go ahead and just write this here, divide by 4, x is -8. So there's my first consecutive number. So what are the numbers? They are, so the numbers are now, -8 was the first one, so the next one would be -7, -6, and then -5. And so, what's my double check on that? Well, we should add them together and see if they sum up to -26. So the first two are -15, and then the second two are -11, so that is -26. So it does check out. So those are my numbers there. Okay, that's pretty cool. We can use linear equations like this. Okay, let's look at number 5. Okay, number 5 says a book has X pages. They've told us what the variable is in this one. How many pages are in the book if Maria read 45 pages of a book Monday, half the book Tuesday, and the remaining 72 pages on Wednesday? Okay, I want you to pause the video and think about that for a while. Try to write an equation that you could solve to find out how many pages the book has. All right, so let's think about this. We want to express the number of pages the book has. So let's start with, let's go ahead and define our variable even though it's up there. So let x be the number of pages in the book. Okay. And so our equation would be, let's just express this as a total because we're given this in parts. How many pages are in the book if Maria read 45 pages of a book on Monday? So she read 45 pages on Monday, so that's part of our total. And she read half the book. We know she read the whole book, so she read 1/2 of X, the total pages, on Tuesday, and then when she was done with that, there were another 72 pages remaining. So the 45 pages, the half of the book, the second day, and then there were 72 remaining. So those number of pages should add up to the total pages of the book. Okay, does that look good? All right, so let's start to solve that equation then. What I'd like to do is get the x terms over on the left side. So I'm going to subtract 1/2 x from both sides. Okay, so what we end up with here is an equivalent equation, and it could be the equation that you started with, that 1/2 x is equal to 45 plus 72. This could have been a reasonable place to start because I could have looked at this and said, well, half of the pages in the book were what she read on Monday and Wednesday, so that would be 45 plus 72. So it's reasonable to start here, but it would have also been reasonable to start at this next stage here. So if 1/2 x, so I'm going to continue over here, 1/2 x is equal to that sum, which is 111 plus 7. Okay, I should have said 110 plus 7. So 40 plus 70 is 110, 5 plus 2 is 7, 117. Half of the book was 117. So if I multiply both sides of this equation by 2, I can find out what the full book was. So Now I have here that 1x is equal to 2 times 117, which would be 234 pages. So the book has 234 pages. Okay, let's look at now at exercise 6. Okay, exercise 6 is a pretty straightforward, we're just trying to find a number. A number increased by 5 divided by 2 is equal to 75. Okay, so define your variable and write your equation, and then come back and check it against mine. All right, so we're going to let x be the number, and so we're going to take that number, increase it by 5, and then divide it by 2, and we're saying that is equal to 75. So again, I'm looking for these keywords. There's my equal sign. Increased by is addition. Divided by, obviously, divided by 2. Notice that I didn't use this division. It doesn't work real well when we're writing algebraic equations. So we're always going to use the fraction bar for divided by. You could also think of that as multiplied by 1/2, right? So I could have written it that way. Okay, so here's our equation. We're halfway done. Now we need to solve it. So to solve this equation, I'm going to start by multiplying both sides by 2 to get rid of that fraction bar there. So I'm going to end up with that going away. So I end up with my x plus 5 is equal to 150. And so I can see that by subtracting 5 from both sides, that x is 145. So x is equal to 145. All right, so that's my number there, and that would be my answer. So the number is 145. All right, let's look at 7. Okay, so attempt number 7, and then come back and check your work against mine. Okay, so let's pick this one apart piece by piece and look for those keywords. So the sum, I know I'm going to be adding here, of 13 and twice a number. So we're going to let, this will be our x. So we can put that down now. Let x be the number. Yeah, that's my question here. What is the number? Okay, so the sum of 13 and twice a number. So this is going to be multiplication here. Twice a number. Is, there's my equal sign. So now I'm going to have two expressions here. It helps me to find my equal sign because now I can write the expressions separately and not get as mixed up maybe. So let's underline the two expressions. So I have 7 less than 6 times a number on this side, and I have 13 and twice a number on that side. What is the number? So the number's the same in both cases. So we're going to have an x on this side of the equation as well. Okay, so you might not need all this, but some people do. So we're going to go through it. So let's get our equal sign in there. Let's write the expression on the left. The sum of 13 and twice a number. So I'm adding two things together. What am I adding? Well, I'm adding 13 and twice the number. There we go. Now on the right-hand side, I've got 7 less than 6 times a number. Well, so something's going to be subtracted here. So 7 less than 6 times a number. So 6 times the number is this. I want 7 less than that, so I'm going to be subtracting 7. What is the number? Okay, so now I need to solve this. Before we were just transcribing these. Now we're transcribing and solving. Looking at this equation here, does that equation appear to have a unique solution? Or is there no solution to that? So maybe you could look at that and realize, oh yeah, the coefficients are different here. I've got 2 on that side and 6 on that side. The constants are also different, 13 and -7. So I know that that equation is going to have a unique solution. There's going to be a number that's true for, and there's only one number that's true for. Okay, so let's start solving that. I would like to start by getting the variable terms on one side. Okay, so I'm going to subtract those coefficients there and come up with, so over here, 2x minus 2x is 0, so I'm just left with 13. On this other side, I've got 6x minus 2x, so that's the same as 6 minus 2 times x, or 4x, and I have a -7. So if I add the, let's see, what do I want to do? I want to add 7 to both sides. And that gives me 20 on the left-hand side of my equation. And I'm just left with 4x over here. And then I can see that x is equal to 5, because 5 times 4 is 20. So the number is 5. And I can put it back in here and check. 13 plus, let me get my arrows here. 13 plus 2 times 5, well, that would be 23, right? Because 2 times 5 is 10, plus 13 is 23. And then over here, 6 times 5 would be 30, minus 7 would also be 23. So I've double-checked my solution there, which you should do for all of these, even if I don't when I'm doing this video. I'm trying to make it a little bit shorter. So, so you should do that. Okay, let's look at exercise 8. Okay, so exercise 8 says, the width of a rectangle is 7 less than twice the length. If the perimeter of the rectangle is 43.6 inches, what is the area of the rectangle? Wow. Okay, so we are being asked to find the area of this rectangle, and we've been given some clues about the length and the width. Okay, so I remember that length times width equals area. So to solve for the area, if I could find the length and width, then I'd be home free. The perimeter of the rectangle is 2 times the length plus 2 times the width. That's going to be my perimeter. Let's look at a rectangle here, a sample. So we'll have length and width. And I could transpose these two. We generally think of the length as being the longer side, but it doesn't have to be. So to find the perimeter, I've got, 2 of these and 2 of those that I need to add together. So that's going to kind of help me over here. So I guess what I need to know is, what do I want my unknown to be? Because I'm going to have an unknown in this. So you're thinking, is it the area? That's what I want to find out. Do I want the area to be my unknown or something else? And the clue is going to be this first sentence here. The width of a rectangle is 7 less than twice the length. That sounds like something that I could transcribe and have a clue for. So what do I want to do here? You could let x be and we only want one variable. So I don't want to say let x be the width and let y be the length, because that doesn't use all the information that I've been given. So I'm going to let x be the length, because it looks like I'm being told what to do to the length to get the width. So if x is the length of our rectangle, then what is the width? The width of my rectangle would be equal to, let's transcribe it here. The width of a rectangle is 7 less than twice the length. So if I take twice the length, because x is the length, the width is 7 less than twice the length. So the width could be 2x minus 7. I could have done this differently. Maybe I could have let x be the width, but it would be harder to write the expression for the length from that. Not that you couldn't do it, but this makes more sense to me. I think it's easier to kind of visualize. All right, so we have some more information here. You know, if we just took length times width right now, we wouldn't have solved for our unknown, because we don't know the area. So, but we do know the perimeter, so we can write an expression using this over here. Expression for the perimeter is 2 times the length plus 2 times the width. So what would that be? 2 times the length would just be 2x, plus 2 times the width would be 2 times 2x minus 7. And we're told that that adds up to 43.6. Okay, so now we've got, we can solve this equation, but let's first use the distributive property here. So this is going to be 2x plus 2 times 2x, which is 4x, minus 2 times 7, 14, is equal to 43.6. So we've got 6x, because that's 2 plus 4x, minus 14 is equal to 43.6. Okay, and my big fat pen is running out of room, so I'm going to just continue on down here. Let's see. Just move. Okay, I can't. So I'm just going to overwrite this here. So let's add, I want to get x by itself, so let's add 14 to both sides here. And I'll get 6x is equal to, the 14 becomes, minus 14 plus 14 is 0. 6x is equal to 57.6. Okay, so I'm getting closer to finding the width here. So I want to divide both sides of this equation by 6 now. Divide by 6, and I'll find out that x is equal to 9.6, what are they? Inches. 9.6 inches. All right, so now I'm going to clear the screen, so make sure you've got that down. Okay, so let's keep going. So x is 9.6 inches, and that's the length. So I can find the width by evaluating this expression here. The width is 2 times 9.6 minus 7. And so that's going to be 12.2 inches. You can work it out. 12.2 inches is the width. And so, but that's not what I've been asked to find. The question here that I'm looking for is, what is the area of the rectangle? So I got to take it one step further. So the area is going to be 9.6 inches times 12.2 inches. And that's going to be 117.12. And the units on that are inches times inches, which is inches squared or square inches. So my area here is 117 and 12 inches squared. Okay, so that one was kind of involved, but if you take it step by step, it's really not that big of a deal. Those ones with lengths and widths of rectangles are pretty common problems, so that would be a good one to study if you struggled with it. So study that solution, maybe watch the video again until it makes sense. Okay, but let's go on to number 9. Pause the video if you haven't done this one yet. Otherwise, you can continue watching for the solution. Okay, so for this problem, we're being asked to find out how many tickets were sold on one of the 5 days where tickets were sold. This equal numbers were sold. So let's read the problem again. 250 tickets are available for sale for a school dance. On Monday, 35 tickets were sold. And then an equal number of tickets were sold on each day for the next 5 days. And so how many tickets were sold on each of those days? So we'll let X be that. So we have a total number of tickets available, and that's 250 tickets. So our total, so we could think of this, total tickets sold are going to be the ones sold on Monday, the number sold Monday. I always like to do kind of these verbal models here because it sometimes helps. So there's the number sold Monday plus 5 times the number sold on the remaining days. Okay, so that's our variable, right? So this is going to be a pretty simple equation to put together. The total tickets is 250. So that equals the number sold on Monday plus 5 times our variable there. So to solve this equation, let's subtract off those tickets from Monday. So there were 215 sold. I like to write that in purple just to show that we're rewriting that equation. 215 sold on those 5 remaining days, so that's 5x. Dividing by 5 gives me how many were sold each day. So 5 divided by 5 is 1, leaves me with x. 215 divided by 5 is, 43. 5 goes into 215, 43 times. So 43 tickets sold each of those 5 days. Okay, and I can double check that by, taking 5 times 43 and adding the 35. Okay, so that was a pretty straightforward one compared to number 8, but that's okay. You can do all of these. All right, so let's look at number 10 now. Go ahead and pause it if you haven't tried it yet. All right, number 10 says, Shauna skateboarded for some number of minutes on Monday. Then on Tuesday, she skateboarded for twice as many minutes as she did on Monday. And on Wednesday, she skateboarded for half the sum of minutes from Monday and Tuesday. Altogether, she skateboarded for a total of 3 hours. So how many minutes did she skateboard each day? All right, so our first thing we need to figure out is how do we want to define our variable? So we want to just kind of reread the problem and think so she skateboarded Monday, Tuesday, and Wednesday. And so our variable will probably be one of those. So we can think in terms of, let's read it and see what it says. So some number of minutes on Monday. So that seems reasonable that we'll let X be that. So let X be the number of minutes on Monday. Okay, so the number of minutes that she skateboarded on Monday will be our X. All right, and then I can see that on Tuesday, she would have skateboarded twice as many minutes as she did on Monday. So Tuesday, not equals, let's do something different here. Tuesday, she boarded for 2x minutes. So twice Monday. So let's reread Wednesday. Wednesday, she skateboarded for half the sum of the minutes from Monday and Tuesday. Okay, so the sum of the minutes, so on Wednesday she boarded for, the sum of Monday and Tuesday would be 2x plus x. And they're saying half of that was her Wednesday total. So now we have three expressions. X is the number she skateboarded Monday, 2x on Tuesday, and then kind of 3x over 2 on Wednesday. So we can put that together because we know that she skateboarded for 3 hours. So we know that X plus 2x, there's Monday plus Tuesday plus Wednesday, and I'm going to simplify Wednesday, that's 3x over 2 is equal to 3 hours. But let's think about this. What do I want to do here? X is in minutes. So all of these are going to be in minutes. So let's go ahead and express our 3 hours as minutes. So what would that be? Let's go ahead and erase this. So instead of 3 hours, let's put in minutes. So that would be 3 times 60, right? 180 minutes. Okay, and then our equation will work out. If we'd left hours there, then we would be getting X in hours, and obviously we want it in minutes. That's what we're being asked for here. So, okay, so now we're ready to simplify this equation. So I'm going to give myself some more room here. So make sure you have this down. And, okay, so what I need to be able to do is add the coefficients of these X terms together. So what I have is, this is a 1x, right? So I have 1 plus 2 plus 3 halves times x is equal to 180. So I used the distributive property and factored out the x. Okay, so this is going to help me simplify this a little bit easier. So if I think of this, I've got 3. 1 plus 2 is 3. 3 halves is 1.5. So I have 4.5. And so I can write that as a mixed number, but I'd rather write it as an improper fraction. So what am I going to have? Okay, so I've got 4.5, which is the same as 9 halves. So we could really have thought of this. Let's go back just so that's really clear. So 1 is 2 halves, 2 is 4 halves, and this is 3 halves times x. So it's 4 plus 2 is 6, 9 halves x. And these are always equal to 180. Okay, so let's take this up here. So we've got 9 over 2 times x is 180. So I'm going to multiply by the reciprocal. This is why using fractions works really well sometimes instead of using like a mixed number, because I can see what I need to multiply by to get my 1x. So I have here, now this part becomes 1, so this is just x. And now I just have to multiply out 180 times 2/9. So I can see that there's a factor of 9 in 180, which leaves 20. 20 times 2 is 40, and I know that that's minutes. So that's 40 minutes on Monday. I'm being asked each day, so 40 minutes on Monday, twice as many on Tuesday, so that's 80 minutes on Tuesday. And then half of the sum, so the sum is 120, half of that would be 60 minutes on Wednesday. And then I have to double check that that's 3 hours, and it is, because this is 1 hour on Wednesday, and this is 2 hours together on Monday and Tuesday. Okay, that was a great one. All right, let's look at number 11, and then we'll be done. All right, looking at exercise 11 here, we have similar triangles. We are told that these triangles are similar to one another. So, and we're being asked to determine the length of AC, which is right here, and BC, which is right here. And those are algebraic expressions, 10.3 minus x and 5x minus 0.3. So we're being asked to find those lengths. So I know some things about similar triangles, and so I'm going to use that so we can write these ratios. So we could say that the ratio of A prime C prime to AC is the same as B prime C prime to BC. And so if I put in those lengths that I'm given, then I have A prime C prime is 18, and AC is 10.3 minus x. That would be equal to the ratio of 38 to 5x minus 0.3, and that's going to be in millimeters. I could write this another way, right? Because the other thing that's true here is that AC to A prime C prime is the same as BC to B prime C prime. So what would that look like as an equation? Well, that would just be these upside down, right? AC is 10.3 minus x, A prime C prime is 18. And then over here I would have 5x minus 0.3, and down here I would have 38, okay? But we're going to solve this. This is a proportion, right? I've got two ratios set equal to each other. This is a proportion. So I'm going to realize that the cross products are equal to one another. So I'd have 38 times 10.3 minus x is equal to 18 times 5x minus 0.3. Well, notice that the cross products in both of these proportions are the same. So it's going to lead to the same equation in the end, which is going to be this one. It's going to be 18, let's get a different color here. It's going to be 18. Now remember, grouping symbols, when you have a fraction bar, that's actually a grouping symbol. It's the same as if you had parentheses. So that's why we don't need to put them here. But when we write it as a multiplication sentence or expression, we need to use the parentheses to show that 18 is multiplying everything here. So this is 18 times 5x minus 0.3, and that's equal to 38 times 10.3 minus x. All right, so that's the equation we want to solve. And so I'm going to clear the screen here, so make sure you've got all that down. And we'll get some room to solve this equation. Okay, so this becomes kind of a calculator problem. Not that you couldn't do these numbers on your own, but this is reasonable that you would use a calculator on a problem like this. So let's go ahead and distribute the 18 and the 38 for our first step. So 38 into here, and we would get 90x, 18 times 5, minus 5.4 is equal to 38 times 10.3 is 391.4, and then 38 times x, so minus 38x. All right, so that is our first step. So now I can, I'm going to use my properties of equality to solve. So adding 38x to both sides. As much as you can do in your head, you probably should. Let me write that in blue. Because it keeps your brain sharp. But if it's just really slowing you down, then you should use a calculator. Okay, so as I straighten this out, I have a new equation here. It's going to have the same solution. 128x minus 5.4 is 391.4. This 38x and negative 38x became 0 on that side. Okay, so now I'm getting close to having the x term by itself. So the thing I need to do next now is to add this 5.4. Okay, this I can do on my own here. So I've got 128x here, and that's going to be equal to this sum. So I've got 396.8. So then my next step, I'll show that in orange again, is going to be to divide by 128 to get x by itself. And this actually comes out evenly. We don't have to round it. Let's see what we have here in blue. So x, this becoming 1 here, x is equal to 3.1. All right, so x is equal to 3.1, but that's not a complete solution yet because you were asked to find those side lengths. And so, so we want to find out what AC is. AC is equal to something, and BC is equal to something. So my expression for AC is, these are those expressions. So AC was 10.3 minus x, and BC was 5x minus 0.3. So I just have to put my value for x in there and solve it. So AC is going to be 10.3 minus 3.1, which is 7.2 millimeters. So there's one result there. And then BC is going to be 5 times 3.1 minus 0.3. So this is going to be 15.5 minus 0.3. So this one is going to be 15.2 millimeters. So that will answer what the question was asking. Okay, so we have seen several applications, and we've got to practice some really great problems here. Ones that you couldn't do by mental math, really. A couple of them you could, but the rest of them you really needed to use your skills of solving equations, setting up a variable, and all of that to do it. Okay, so remember that you will be skipping number 1 on the exit ticket and also on the problem set because we didn't do that example in this lesson. Okay, good luck, and we'll see you back here for lesson 10.